How you doing today? My name is Jeremy Heron, and today I'm going to be talking about t-tests. Sarah Cooker and myself both worked on this project that we're about to present, and I hope you enjoy it. The t-test. We use a t-test when we're trying to determine the differences in means. This is a hypothesis test that examines the null hypothesis. The means for both groups are equal, versus the alternative hypothesis. The means are not equal, or the mean for one of the groups is larger than the mean for the other group. We use t-tests when our independent variable is a nominal level variable with only two categories or groups. Categorical variable, also called a nominal variable, are not ordered categories. We also use a t-test when our dependent variable is an interval ratio level variable. An interval variable is a measurement where the difference between two values is meaningful. There are two main types of t-tests: a t-test for independent means and a t-test for dependent means. A t-test for independent means tests two distinct groups or categories in the sample. Each group was only measured once on the dependent variable. A t-test for dependent means tests one group of participants where each participant is tested twice, or two groups of participants where each participant in one group has been closely matched on some characteristics with a participant in another group. These can be called paired or matched samples. This is an example of an independent means t-test. I got this from the week 4 homework assignment for t-tests. The question that they're trying to determine is which gender, male or female, has a stronger belief that it's better to acquit guilty people than convict. Okay, if you look in the first section, if you look right here in N, it respectively says that 76 males and 245 females participated in this study. The average score for males was 4.84, and the average score for females was 5.61. When actually reading an SPSS output, you would go to the significance right here, and the significance says 0.52. Now, to read the correct data for this figure, you could refer to Levene's test for equality of variances, right there. Levene's test for equality of variances basically states if the significance is higher than our standardized p-value of 0.05, we could assume that equal variances are assumed, and we would read the first line of data. So our t-value here would be a negative 2.245 because our significance is higher than 0.005. Now, if that significance was lower than 0.005, we would read the lower level data stating equal variance is not assumed. Okay. The t-value then, based on that, is our negative 2.245. The degrees of freedom are 319. And if you are wondering what degrees of freedom are, if you don't remember from week 4, degrees of freedom are the amount of people in your population. So there's two groups. You have a male group and a female group, both accounting for 1. So 76 plus 245 gives you 321. And then for your degree of freedom, you subtract both of those male and female from the population. So 321 minus 2 will give you 319. That's your degrees of freedom. They're the number of people in your population or your sample. So that being said, our p-value, again, we're going to refer back to the significance here of 0.52. Now, the 0.52, again, is higher than our standardized significance of 0.05, meaning that there is not a statistical significance between male and females in their beliefs of whether to acquit or convict guilty people. Okay, another example for a t-test is dependent means t-test. This was also from our week 4 homework assignment. And basically what the question was, is there a statistical difference between anxiety levels when looking at a spider picture or looking at an actual spider? This is a paired sample dependent means test because, again, this is one group of people that were tested 2 different times. Okay, it says how many people were compared respectively. Again, we're going to go up to our N. That's our population. There was 12 people that were tested. One was shown a picture of a spider, and then again showed an actual spider, and then their anxiety levels were then calculated. Okay, so it says 12 people were in the sample. The average scores for the picture spider was 40, and the average scores for a real spider was 47. Our t-value would be 2.743, and our degrees of freedom would be 11, because there was 12 people in the sample, minus the one group of samples. There was only one sample group here. They were tested 2 different times, and we were only dealing with 1 sample, so you only subtract 1 from that figure, which would give us an N population of 12 minus 1 would give you 11 in degrees of freedom. So again, we're looking for p-value significance. And if you go all the way to the end, our two-tail significance is 0.31, which is less than our standardized p-value of 0.05, stating that there is statistical significance. So to answer the question, yes, there is a statistical difference in anxiety levels between the sample when looking at an actual spider and then looking at just a picture of a spider. So the difference is, we know that there's a difference in that sample based on our significance, which comes again less than our p-value of 0.05, meaning there is a statistical significant difference in the samples. Okay, a web resource that I've used throughout the length of the course has been sagepublications.com. If you log on to the sagepublications.com website from this link, to the left there is a bunch of valuable resources on t-tests, regression, a lot of things that we've been working with in the class. It's been super helpful to me throughout the class. Hopefully you can refer back to this when you may be struggling or need some clarification on some things. Thank you very much for taking the time to watch our video. Have a good day.